Okay, good morning students. So last class we discussed about the topic is what is the capacitors. So the energy stored in a capacitor, what is the capacitors, and so how many types of the capacitors, and also so the capacitors are connected in a series combination, and also we discuss in a parallel combination. You got it? So what is the capacitor? So capacitor means so the energy stored device is called as a capacitor. Energy stored device is called as a capacitor. And so the capacitor we can write okay. So the circuit symbol of the capacitor. So that is called as the. So this is the first plate and the second plate of the capacitor. And so the capacitors are connected in a series combination. So the final capacitance, the effective capacitance, so 1 by C is equal 1 by C1 plus 1 by C2 plus 1 by C3 plus etc. is taken. Okay, so the capacitors are connected in series combination. Okay, got it. So now the capacitors are connected in parallel combination. So the effective capacitance or final capacitance or resultant capacitance C is equal C1 plus C2 plus C3 etc. is taken. So this is called as effective capacitance in series combination. So this is called as the parallel combination. So the effective capacitance. Okay. So now today discuss the another topic. So that is called as the effective capacitance or in the capacity. The two plates of two conductors of the two plates are connected in a parallel combination. Okay, parallel. So that means here taken. So this is called as a first plate. Okay, first plate. And this is called as another plate is taken. These two plates are parallel plates. Okay, parallel plates. So this is the first plate and this is called as second plate. So this is total is called as a positive. Okay, so it's taken positive. And now we have taken that is the totally negative. Okay, so now the arrow marks are indicated. So the electrical field direction positive to negative. The electrical field lines is passing through the positive to negative. So the area of the plates is taken A, and here also. This is called as a first plate and this is called as a second plate. Sigma is called as a surface charge density. Surface charge density here also. Sigma is equal surface charge density. Surface charge density. Okay, got it. So here taken the electrical field lines is passing through the positive and negative, and these two plates are conducting. Okay, parallel. Okay, these two. Now to find out the capacitance of the two parallel conducting plates. Parallel conducting plates. So this is called as a, these are two plates. This is total positive, this is the total negative. These two plates are conducting or parallel conducting and separated by the small distance in a vacuum. Okay, so separated the small distance, so that is called as a D. So D is taken the distance between the two plates. D is called as the distance between the two plates, separation between the two plates. The two plates are placed in a vacuum or air. Okay, వాటిని రెండు ఎక్కడ ఉంచుతున్నాం, మనం గాలిలో ప్లే చేస్తున్నాం. ఓకే, ఒక ప్లేట్ మొత్తం ఏముంది మనకు పాజిటివ్ ఉంది, ఇంకొక ప్లేట్ మొత్తం ఉంది నెగటివ్ ఉంది. దీస్ టూ ప్లేట్స్ ఆర్ సెపరేటెడ్ బై ఏ స్మాల్ డిస్టెన్స్, దట్ ఈస్ ఆర్ ఆర్ డి is taken. Okay, got it. So here the area of the first plate A and the area of the second plate is also A. A be the area of the plates. A be the area of the plates. Got it. Now here taken, so sigma is called as a surface charge density. Sigma is called surface charge density. So surface charge density means sigma is equal to Q by A. Okay, so Q means charge, A means, so that is means, so for example, general equation we can write charge density rho is equal to M by A, M by or B. Okay, so mass for unit volume. Mass for unit volume is called as a density. But in here that is the cube is the total charge and area is taken here, that is called as a density. Surface charge density on first plate is taken, sigma is equal Q by A, that is called as a plus Q by A. And on surface charge density on the second plate is taken, minus the sigma is equal to Q by A. Okay, got it? So now we have taken the consider the first plate and second plate. Now to find out the effective capacitance of the two parallel plate capacitors. To find out the effective capacitance of the parallel plate capacitors. Now we are given the first plate and given to the second plate. These two plates are separated by the small distance in a vacuum. So these are positive, these are total negative. Okay, got it. So here is the area of the two conducting plates. Okay, sigma is called as a surface charge density. Surface charge density. Now, so the electrical field lines is passing through the positive to the negative. Electrical field lines is passing through the positive to negative. Okay, got it. Now here taken, that is called as a electrical field intensity. Electrical field intensity inside of the two plates. Not outside, inside of the two conducting plates. Inside of the two conducting plates, that is called as a E is equal to 2 epsilon by D. So 2 epsilon by D, already we know that, or to find out the electrical field intensity in a 4th chapter. Okay, so the electrical field intensity due to a plane sheet charge. Okay, due to a plane sheet. So that is called as a E is equal 2 epsilon by D. So E is equal 2 epsilon by D is called as a electrical field intensity due to a plane sheet. Okay, plane sheet. Plane sheet means oka taranga unnatuvanti oka sheet valla vachatuvanti electrical field intensity is equal to epsilon by D. Same pattern here also like that. So this is called as a surface. This is called as also another surface. That is also compared to the sheet. Okay, so sheet equation ni మనం ఇక్కడ అప్లై చేస్తున్నాం అంటే మనం ఇక్కడ అప్లై చేసేటువంటి ప్లేన్ షీట్ కు ఎంతైతే ఎలక్ట్రికల్ ఫీల్డ్ ఇంటెన్సిటీ ఉంటుందో సో ఇక్కడ కూడా సేమ్ అంతే ఇంటెన్సిటీ ఉంటుందని అది ఇక్కడ ఇన్సైడ్ అవుట్ సైడ్ ఇస్ 0. ఓకేనా, అవుట్ సైడ్ ఆఫ్ ది ఫీల్డ్ 0, అవుట్ సైడ్ ఆఫ్ ది ఫీల్డ్ 0, అవుట్ సైడ్ ఆఫ్ ది సెకండ్ ప్లేట్ is 0, బట్ ఇన్సైడ్ ఆఫ్ ద ఎలక్ట్రికల్ ఫీల్డ్ ఇంటెన్సిటీ, ఇన్సైడ్ ఆఫ్ ది electric field intensity E is equal to 2 epsilon by D plus 2 epsilon by D is the second plate. Okay, so the electrical field intensity E is equal to 2 epsilon by D, 2 epsilon by D. Okay, or epsilon, that is nothing but here taken, so epsilon by D. Okay, epsilon by 2 epsilon by D. So epsilon by D plus epsilon by D. Okay, so 2 epsilon by 2 epsilon by 2D is taken. So 2 bar cancel, epsilon by D is taken. So the electrical field intensity inside of the field. Now, so the electrical field intensity E and so the potential difference V. The relation between these two, E is equal to V into D, or V is equal to E into D. Okay, so this is a relation between electrical field intensity and potential difference. The relation between electric field intensity and potential difference is taken. V is equal to E into D. But here E is equal to epsilon by D. Okay, so here that is nothing but sigma is equal to Q by A. Okay, so here taken that is equal to the taken E is equal to epsilon by D. E is equal to epsilon by D. E is equal to epsilon by D. Okay, so but sigma is equal to Q by A. Sigma is equal to Q by A. Okay, got it. Okay, right. So now here that is E is equal to sigma by epsilon. Okay, E is nothing but here taken sigma by epsilon. E is called as a electrical field intensity inside of the inside of the two charged plates. Inside of the two charged plates is E is equal to sigma by epsilon. And also the second plate is taken sigma by epsilon. E is called as a electrical field intensity. E is equal to sigma by epsilon plus sigma by epsilon 2 sigma by epsilon 2 epsilon 2 are cancelled. So remaining equation we can write sigma by epsilon. Sigma by epsilon. Got it? So sigma already we know that Q by A. So that is called as a Q by A epsilon. Q by A epsilon. Got it? So but the relation between electrical field intensity and potential difference is taken. So V is equal to E into D. Okay. So V is equal E is equal Q by A epsilon into D is taken. Okay. So C is equal capacitance is equal. So C is equal Q by V. C is equal Q by V. But here the taken, so that means so V is equal Q by A epsilon. E is equal substituting and D. So that is means so here taken, so 1 by V is equal A epsilon by Q into D. So Q is taken. Q by V is equal to A epsilon by D. So Q by V is means C. So C is equal A epsilon by D is called as the effective capacitance of the capacitor inside of the two conducting plates. C is equal A epsilon by D. Okay, got it? So V is equal E into D. V is equal Q by A epsilon. Q by A epsilon into D. So A epsilon that is means reverse is taken 1 by V because so C is equal Q by V. So capacitance C is equal Q by V. So already V. So 1 by V taken. So here the right A epsilon by Q into D. So Q is taken outside. So Q by V is equal A epsilon by D. Q by V is equal A epsilon by D. Q by V means C. C is equal A epsilon by D is called as a capacitance of the capacitor. Okay, so parallel conducting two plates. Parallel conducting two plates. Okay, got it? So A is area of the plates. D is means distance. So epsilon is the constant. Permeability is constant. Okay, depending on the medium. Okay, C is equal A epsilon by D. Got it? So the energy stored in a capacitor. Next topic, energy stored in a capacitor. Energy stored in a capacitor. Okay. So energy stored in a capacitor. How much energy will be stored in a capacitor? Okay. To find out. Now is taken. So the first of all empty capacitor. Okay, empty capacitor is taken of a capacitance is C. Now first of all is taken empty capacitor of a capacitance is C. And so the charge is given to the capacitor. The charge is given to the capacitor up to the potential difference to reach V. Okay, got it? We consider So empty capacitor, uncharged capacitor, that is capacitance is taken C. Okay, so the charge is given to the capacitor up to reach the potential difference V. Okay, up to reach the potential difference V. So average potential difference, average potential difference, average potential difference is equal. So V0 plus V by 2 is equal to V by 2. Okay, so first is empty. Then the charge is given to up to reach the potential difference. And ఈ రెండు పలకల మధ్య పొటెన్షియల్ భేదం అనేది V ని చేరేంత వరకు దానికి చార్జ్ ఇస్తున్నాను. ఓకే, గాట్ ఇట్. దానికి చార్జ్ ఇస్తున్నాను. అంటే చార్జ్ ఇచ్చుకుంటూ వెళ్తున్నాం ఎప్పటి వరకు టు రీచ్ ది maximum potential difference between the two plates of a capacitor, that is the V. So the average potential difference first 0 and the potential V, so the average taken V by 2. Okay, got it. Now, so the work done. So work done is equal to W is equal to the charge Q into V by 2. Q into V by 2. So work done W is equal to QV by 2. Work done W is equal to QV by 2. That means, so this is called as the total work done. The work done will be stored as a potential energy. The work done will be stored as a potential energy. So the potential energy U is equal to Q into V by 2. QV by 2. So this is called as a energy stored in a capacitor. But we can write the another form also. Okay, C is equal to Q by V. So Q is equal to C into V. Okay, write in the equation. So U is equal to Q is equal to C. So C into V by 2. So Q plus substituting Q is equal to C into V. So C into V by 2. That means so CV square by 2. U is equal to CV square by 2. Okay, got it. So but V is equal, we can write Q by C. C is equal to Q by V is equal to Q by C. So Q by C, substituting in the equation. Okay, C into V square means Q square by C square by 2. C are cancelled. So Q square by 2C. Okay, so these are total energy stored in device. U is equal QV by 2 is equal CV square by 2 is equal Q square by 2C is taken. This is called as a total energy stored in a capacitors. Okay, got it. So now further discuss so the battery is disconnected to the capacitor and battery is connected to the capacitor. So how much energy is left to the capacitor? Okay, so further class.